we have a function which is this. Looks like a cosine function that's been multiplied by 6, so it's 6 times bigger, and then moved up by 6 between 0 and 4 pi. Here's the graph of y equals f of x. The graph f touches the x-axis at points A and B. The shaded region is enclosed, but we've got a shaded region here, great, between the points A and B. Find the coordinates of A and B. Well, if I notice this is a graph that's been multiplied by 6, so it would have been a cosine graph like this, and that would have been 1 now, that's 6 either way. It's a cosine graph where these are the minima of the cosine graph because it's been moved up by 6. If that's now 6, it was on this axis, it's been moved up by 6, that makes sense. It just touched there and there. And so I look at a cosine graph and say cosine graph looks like this between 0, 2 pi and 4 pi. So I want the two minimum points here and here, which is actually at pi and 3 pi. If we want to check that, let's just check it and see. So we've got, these are points on a graph, so use f of x. So we've got 6 plus 6 cosine x equals 0, gives me 6 cosine x equals negative 6. Cosine x equals negative 1. Oh look, we're looking at a cosine graph. Here's negative 1, and it meets at pi and 3 pi, so we were correct. So A is the first one, equals pi. B is the second one, equals 3 pi. Show the area of the shaded region is 12 pi, so I want the area of this. Well, that's a nice curve, and we're finding the area under a curve, so I can just integrate. So we do the integral between 0 and 3 pi of 6 plus 6 cosine x dx. Let's take that somewhere where we've got a bit more space because... So I'll go down here and look at separate space on a separate page. So I want the integral of that, which gives us, integrate this one term, another term, because it's separated by plus or minus, so we can do them separately. 6 goes to 6x. 6 cosine, well, the 6, it doesn't matter. Cosine integrates to sine x. Positive cosine integrates to positive cosine x. That should be a 0, that should be a pi. Between pi and 3 pi, which is 6 times 3 pi plus 6 times sine 3 pi. Subtract 6 times pi plus 6 times sine pi. Let's look at the sine graph and see where we go. Sine graph here, 0, 2 pi, this must be pi. Oh, sine pi is 0, if we go to 3 pi as well. Oh, sine of 3 pi is 0. So this equals 6 times 3 pi is 18 pi. Plus 0, subtract 6 pi, subtract 0, which equals 12 pi, which is what we wanted to show. It says the right code in the following diagram. Right code has a total surface area of 12 pi. So we've got to take into account the curved surface area and the area of the base equal to the shaded area in the previous diagram. So now the area is 12 pi. So area is going to be our pi r squared plus pi lr for the area of the curved surface from the formula booklet. It's got pi r, and pi r squared is the base. We know what r is, we know what the area is. The area is 12 pi equals pi times 2 squared plus 2 pi l. 12 pi equals 4 pi plus 2 L pi. I'll put that, divide everything by pi. 12 equals 4 plus 2L. 2L equals 8. L equals 4. So now I've got the stand height of 4. Find the value of L. I've done that. Hence, find the volume of the cone. Volume of the cone is pi r squared h over 3, which gives us pi times 2 squared h over 3. And we need to find h. We'll look at this now. This is a nice right angle triangle we can look at, which you can see if you could slice this down the middle of the cone, you'd see that right angle triangle. Right angle triangle would use Pythagoras. So h squared plus 2 squared equals 4 squared. H squared plus 4 equals 16. H squared equals 12. So h equals root 12. H is greater than 0 since it is a length. So now we can put this equals 4 pi root 12 over 3. And that does simplify a bit. 4 pi root 12 is root 4 root 3, which is 2 root 3. So 2 root 3 over 3, which is 8 pi root 3 over 3.